Okay, first of all, we're going to have a look at exercise number 1, sorry. Okay, hopefully everyone is well. So kita boleh proceed dengan kita punya exercise number 1 based on our previous example. Uh, okay, exercise number 1, a simply supported rectangular beam of 6 meters span. So here is already mentioned here, span dia 6 meter, which means actually dia punya length lah. Okay, length dia 6 meter. Okay, and then we have it carries a characteristic that including self weight of beam. So maksudnya sekarang termasuk dengan self weight of beam sendiri, which is GK akan jadi 45 and QK is 10. So sebenarnya you boleh view terus dalam the drawing given here ataupun illustration given here. Kalau tak ada this illustration, you kena pandai-pandai how to say imagine lah, and then you can draw your own illustration so that benda ni reflect balik soalan senang kita nak faham. Okay, the beam is composed of grade 30 concrete. Okay, so when it says grade 30 concrete, automatically you will know that FCU is equal to 30 Newton over mm square. Okay. So this one, what does it mean? Maksudnya concrete strength adalah 30 Newton untuk 1 millimeter square. Itu maksud dia. And design the bending and shear reinforcement. So the question asks you to design bending and shear reinforcement. Okay, for beam shown in figure, using high yield steel for main reinforcement, okay, and mild steel for link. So apa maksud dia? Yang first one ni, using high yield steel for main reinforcement. Okay, you know that main reinforcement, if it say high yield steel, it means that Fy will be equal to 460 Newton over mm square. Okay, kita dah tahu because high tensile steel ini adalah dia punya strength. Because kalau kita refer pada our notes, ada benda tu, you boleh tengok notes you yang sebelum ni lah, ada share. And also here we have mild steel for links. Maksudnya F1 ni main bar, main steel, main reinforcement, suka hati you lah nak panggil apa, ataupun kita pun boleh panggil dia bending reinforcement lah. And for link, kita boleh panggil dia link, kita boleh panggil dia shear reinforcement. Dia adalah benda yang sama Okay, FYV maksudnya this one adalah strength of steel untuk link. Okay, FYV. Okay, it is 250 sebab mild steel. Okay, link dia mild steel, so the strength only 250. Okay, alright, and then assume, okay, here you know that this is diameter of bar. Okay, maksudnya sekarang main steel, main reinforcement, main bar, apa sajalah bending reinforcement, okay, size dia minta 20 mm. Okay, dalam example kita sebelum ni memang kita tak ada mention about the size of bar. Okay, maksudnya kita assume sendiri based on our assumption, so kita design. But here dia dah suruh you untuk design using 20 mm. So you kena design based on this size. Okay, tak perlu assume. Okay, and another one also given here, the diameter for link ataupun for shear reinforcement, it is 10 mm. Also given, jangan assume. Kita pakai saja whatever given here. Okay, and as you see in the illustration also kat sini, nampak ada cross section of beam. So from this cross section, if you see D also given, which is 547 mm, and B is given 325. Okay, so this is all the information given. So bila you tengok dalam this exercise 1, you know that this is almost similar to our example number 2. Okay, because dalam example 1, whatever given, the information yang dia bagi adalah dia bagi H. Okay, tapi H tu maksudnya the depth, dia panjang. Maksudnya H tu dia bagi this one kan, in example number 1. Okay, dia bagi H. Okay, but here, okay, dia tak bagi H, dia bagi D. So D, when D is given, it is actually similar to example number 2. And also kita kena take note bila dia kata yang characteristic dead load also include self weight of beam. Meaning you don't have to calculate self weight separately. Macam example number 1, kita kena calculate dia kan. Okay, but sebenarnya kita boleh calculate self weight. Kalau katakan dia tak ada kata including self weight of beam, kita boleh calculate self weight of beam. Macam mana kita nak kira? So kita kan ada formula H equal to D plus 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 C tu kan. Kita boleh kira dapatkan H, and then kita boleh kira dia punya self weight. Macam mana kita kira? B darab H darab dengan 24 kN per meter cube. Kita boleh dapat self weight actually lah. Okay. Tapi dia dah bagi tahu dah inclusive, included already. Okay. We don't need to calculate it separately. Okay. So our job lebih senang lah. Okay, we can first, normally when we design, we going to start with loading punya calculation. So kita akan start kira loading. Okay, hopefully everyone boleh follow Okay, calculate loading. Okay, how we going to calculate loading? Okay, kita refresh balik. Okay, the formula of ultimate design load ataupun W. Okay, ultimate design load W is equal to 1.4 GK plus 1.6 QK. Alright, and then just masukkan je directly the value of GK, which is, okay, tengok sini GK 10, QK 45. So we can just masukkan je inside this what is it? Formula. Maafkan tulisan saya yang bodoh ni. Oh my god, buruk itu sangka. Okay, betul?
86 Newton.
86, yes. True, 86. 86 kilonewton per meter. Okay. Okay. And then when we dah calculate loading, apa yang kita buat next? Normally kita akan kira main steel. Okay. Kita akan kira main steel. Kenapa kita nak kira main steel? Kita nak tahulah size apa kita nak pakai. And to calculate net main steel, normally kita akan start dengan calculate M. Okay. Which is ultimate design moment. Okay. M. The formula again, it is WL square over 8. Alright. So W, it is 86 kilonewton per meter times the length given in the question, it is 6 meter here. So ambil je 6 meter ni. Okay. Here 6 meter and power of 2 we divide by 8. Right. Good. Okay. Ada sesiapa nak kira untuk saya? Dayang Azizah.
387.
Berapa?
387.
387. Okay, so it is 387 kilonewton meter. Okay. So here it is like 86 kilonewton for 1 meter. Okay, so since kita punya ni berapa panjang dia, like 6 meter kan. Okay, so sebenarnya macam tu lah. Okay, so kita sebenarnya tengah lukis benda Allah ni benda Allah. Ayo, apa ini? Okay, SFD, BMD. Ya. Ini dia maximum bending moment using this formula lah. Okay, kita pakai formula ni. Kita terus dapat this maximum bending moment without the needs of nak lukis SFD and BMD. This is like shortcut ni cara Okay, and after that, kita mesti compare dengan ultimate moment resistance, which is formula is mu equal to 0.156 FCUBD square. Okay, masukkan your formula. Okay, value of FCU is, kita dah tahu grade 30, kita dah tulis dah kat sini, kita dah take note. Okay, so kita just use this value 30 ni. Okay, 30 Newton over mm square. Alright. And then kita darab with the B. B given in the question, it is 325 and D is 547. Okay. So 325 and 547 power of 2. Okay. So we're going to get the value of ultimate moment resistance. Okay. This ultimate moment resistance, Davis,
Yes, madam.
berapa? Kira dulu. 557. Lepas tu ada lagi nombor kat belakang. Kan nombor
889.
Ha?
889.
889. Betul. Okay.
Tapi dah
455,097.
96.
madam.
Ya dah, dia run off madam.
I malah nak kira. Alright. 096889. So ini unit dia Newton millimeter. So kita convert dia jadi kilonewton. 455.097. Begitulah. Okay. Alright. Okay, bila kita dah calculate M and MU, we're going to compare M and MU. Whether M ni lebih besar MU ke, MU lebih besar pada M ke, okay. But bila kita tengok sini, kita compare, another thing, I lupa tadi nak beritahu, okay, D kat sini, 547 given, jadi kita tak perlu nak kira D lagi macam yang kita buat masa example 1. This is more like example number 2 Kita pakai je value of D, no need to calculate D, whatever again. Okay, and okay, kita compare. So M, we see here is less than MU. Okay, so maksudnya sekarang bila less than MU ataupun you nak tulis MU is bigger than M pun boleh, sama je. Okay, maksudnya sama. So maksudnya apa? No compression, panjangnya, reinforcement is required. Okay, I pendekkan. So kita tahu when this, what we got, we can design it as singly reinforced concrete beam. Okay. Level malas menulis. Okay, when we know, so kita tahu our design going to be like only only tensile steel saja ataupun tensile bar saja dekat bawah, tak ada compression bar kat atas. Okay, maksudnya ini adalah singly punya design Kalau doubly baru ada yang kat atas ni, actually it act as compression bar. Okay, kalau tak perlulah. Okay, alright. So we are done with this. Dah compare. Okay, kita tahu. Okay, kita boleh design dia as singly. So bila kita dah boleh design dia as singly, kita next step is kita nak cari AS. In order to find AS, we need to find K and Z level arm Okay, so we proceed with K. So K is M divided with FCUBD square. Okay, Masukkan balik value M yang kita dah ada earlier. So we know that the M is 387. Convert it into Newton millimeter. Means that you need to times 6. Maksudnya darab 1000, darab 1000. So darab 10 kuasa 6 lah. And then you bahagi saja dengan FCU. So FCU also kita dah tahu it is 30 Newton over mm square. And the B is 325 and the D is 547 mm. Power of 2. Okay. Siapa yang nak tanya? Azirah Shazlina. Nur Azirah Shazlina.
Ya, Miss.
Okay, so you kira dulu dapat dah?
0.1327.
So 133 lah kan? Bila 3 decimal places, 133
Yeah.
lah. Okay, so 0.133. Thank you. Kita kira level arm. Okay. D 0.5 plus square root 0.25 minus K divide by 0.9. Yes, Zah. Okay. So kalau boleh kira lah. So macam mana nak kira, I boleh repeat balik step. Macam mana kira. You kira ni dulu mula-mula. Okay. K bagi 0.9. Okay. And then you ambil 0.25 minus answer yang semua ni. And then you square root kan everything. Okay. And then baru you campurkan semua ni. 0.5 campur answer lah. Okay. So itu step dia. Nak senang kira. Supaya kita tak pakai bracket. Lepas tu kita buat silap Vivian. Okay. Can you answer value of Z?
Hello,
Yes.
dapat dengar kah? 0.819.
0.8
819.
19.
Betul kah, Miss? Ya, saya rushing kira tadi.
0.8 jap. 0.819 berapa?
D.
No. Sebab nombor dia kan panjang kan? 0.819
7.
7 bla 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 lagi, betul?
Ya.
Kan? So bila kita round up, sebab I pun nakkan 3 decimal je. Okay, so mungkin kalau you rasa you nak stick with this number, you can stick with this number lah. Ataupun kita round up je. Sebab kalau kita round up 3 decimal pun dia akan jadi 0.82. Betul? Ini round up pergi sini. Jadi bertambah 1 pergi sini lagi. So dia jadi 0.82 D. Okay? So dia jadi 0.82 D. Alright. So it is 0.82 D. Okay. So after that, kita bolehlah kira AS. So AS formula is M divided by 0.95 FYZ. Okay. M 387 times 10 power of 6. We divide with 0.95. FY kita dah tahu it is 460. Kat sini kita dah ada FY. Okay, 460. Okay. Okay, 460. Masukkan in our formula and okay, Z is 0.82 and you just darab je dengan D ni. Okay, DU you know it is 547 mm. Since kita dah ada value of D, so kita boleh je terus masukkan Ini sebenarnya adalah D, 0.82 D. Okay. So masukkan je lah D tu. Okay. And then kita kira. Okay. Muhammad Yazid Aiman.
1974.
1970
1974.
4
Point 369.
0.369. Betul?
Macam. Maybe betul.
1974.369. So 1974.369. Okay. So kita dah kira as. Okay, noted that in the question, it says that you have to use 20 mm diameter bar. Okay. So when it says 20 mm, kita kena stick dengan 20 mm lah. Okay. Jadi I select kat sini. Kita tengok. Okay. 20 mm. So I direct kat sini. Okay. And we have that value again, which is berapa? 1974 lama. AS kita tadi 1074.369. Okay, we have this value for the AS. So kita kena select, okay, yang size dia, bar size ni 20 mm diameter, berapa number? Okay. Anyone nak try?
1890 Miss.
1890. So, maksud you kita nak pakai 6Y20. Betul? Okay.
Yeah.
Kalau ini 6Y20. Okay. Kalau you pakai 6Y20, okay, because ini adalah minimum number maksud saya steel area ni adalah paling minimum. You cannot go below this number. Okay. Maksudnya AS ni adalah AS yang you must it is required untuk provide banyak ni. Jadi ini yang paling minimum. So kita kena go higher. Okay. So 1890 tak cukup. Okay. Okay, awangku Izzat kata 2200, 7 number of bar. So, awang Izzat kata 7Y20. Okay. 7Y20. Okay. And Vivian also kata 7Y20. Okay, if let's say you pakai 7Y20. Okay. The situation here. Ni I bagi situation sajalah. How you going to arrange that 7 number of bar, you nak arrange dia macam mana? Okay, you nak arrange dia 1, 2, 3, 4, 5, 6, 7. Okay, so kalau macam ni boleh, tapi kita kena risau pasal spacing. Is it enough? Okay, we know that dia punya apa ni, breadth is only 325 mm. So is it spacing dia enough kalau you nak buat dia satu layer macam ni, satu layer bar sahaja? Okay. Okay. Kalau katakan you kata okay miss, why not if kita buat macam ni? 1, 2, 3, 4 kita stack. Okay. 1, 2, 3. 7 kan? Okay. Tapi how about this one? Yang kat sini macam mana? Okay, because we know that, okay, yang kat sini warna biru ni macam mana? We know that when kita nak stack bar, dia mesti balance meaning dia bercouple lah. Dia tak nak hidup bersendirian. Okay, jadi bila kita stack, because stack normally, okay, kalau stack macam ni mungkin muat lah. Spacing mungkin okay. Okay, I cakap spacing yes, okay rasanya. Tak ada masalah because only 4 numbers of bar, perhaps okay lah. Okay, but then our problem is how we going to fit. If let's say kita nak pakai 7Y20, we cannot fit into this small space sebab kita tak boleh buat the in stack punya arrangement. Okay, kita just boleh buat dia one layer saja of bar. So if let's say kita nak buat the stack and dia balance, meaning dia bercouple, dia tak bersendirian, maybe kita kena, we are forced, hidup ini single. Astaghfirullahaladzim. Yalah, hidup single. Okay. Kita kena, kita kenalah terpaksa. We are forced to use 8y20. Okay. Although dia punya, kalau you nampak 2510 dengan kita punya ni 1974, tak adalah besar sangat sebenarnya, tak adalah jauh beza sangat, actually acceptable. Okay, so kita pakai je lah 8y20. Okay, boleh faham? Kalau ada siapa-siapa rasa tak faham kenapa saya tak nak juga guna 8y, saya nak guna 7y juga, saya cuba. I tak tahulah. Alright, so from table ataupun you nak pakai ayat lain pun boleh, suka hati you lah. Kita pakai 8y20, which is the AS is going to be berapa tadi 2500, tak ingat. 10 2510. Okay. Okay, so inilah kita punya bar selection. Okay, bila kita dah pilih macam ni, jadi next step is kita kena check for spacing. Okay. And to check for spacing, okay, I lukis dululah. So we have like 8 numbers of bar. Okay. After that, okay, kita bolehlah kira. So we know that the spacing, when we calculate, we know that this is 325. Okay. Lambatnya keluar. Okay, 325. And okay, we know that, okay, we have to minus, okay, B minus dengan, we have like 4 numbers of bar. We have 4 numbers of bar, meaning that, okay, 325 kita minuskan dengan 4 bar ni. Okay. Maksudnya sekarang bukan 8 sebab you bukan susun dia satu layer. Okay, jadi 4 numbers of 4 numbers of 20 mm diameter. Okay. And then we also have what is it? Okay, we also have link. Kat sini link. Okay, jadi kita tolak dengan link. Tolak 2. We know that link dia punya diameter 10 mm. Given dah dalam soalan, dia suruh you pakai 10 mm kat sini. Okay, ini dia. Dia dah suruh you pakai 10 mm. Jadi kita pun stick with that. 10 mm. Okay. And last sekali, we also have apa nama dalam ni? Concrete cover dekat tepi ni. Okay. So we minus that concrete cover. Okay. 25 mm. Right. And then, so sekarang ni apa yang kita nak? Sebenarnya kita nak ini. Kita nakkan value of this one. Ni spacing yang kat sini, spacing yang kat sini, spacing kat sini. Okay. So right now, ini yang kita nak. Berapa spacing ni? Okay. Berapa ni? Okay, so spacing ni akan jadi sama lah untuk setiap jarak dia tu sama Jadi bila kita nakkan benda ni, kita bagikan sebab ini sekarang ada 3 kan. Spacing yang kita tak termasuk lagi dengan our calculation ada 3. Bagi dengan 3 ataupun kita kira kalau kita pakai yang the one yang I ajar sebelum ni, like pakai formula, tapi sebenarnya dia tak ada formula. 4 minus dengan 1. Okay, because of number of bar minus 1. So 4 bagi 1 minus 1. 4 tolak 1 dapat 3. Okay. Kalau guna apa ni, drawing guna AutoCAD. Boy. Gigihnya guna AutoCAD. Okay, so we are done with bending moment. So bending moment kita dah, bending reinforcement. Bending reinforcement kita dah habis. Okay, dah siap. Okay, next step is kita kena kira shear reinforcement. Okay. Okay, so shear reinforcement, we going to start with kira apa ya? Kita akan kena kira berapa value V, okay? Which is the maximum shear force. Kita nakkan maximum shear force. Okay, but in order untuk kira maximum shear force, kita kena ambil dulu value of W. Okay, so W ni, kita dah tahu the value of W is 86 ataupun ataupun design load kita ultimate design load kita lah 86 kilonewton per meter. Okay, sebab 86 kilonewton ni per meter, so kita nak dia lah untuk 1 meter, tapi kita dah tahu beam tu adalah 6 meter long, so kita boleh terus darab 6 meter. Okay, so here I dapat 516 kilonewton. Okay, and then we know that, okay, since beam ni, kita tahu beam is symmetrically loaded. Macam salah je. Okay, apa maksud symmetrically loaded? It means that, okay, you ada your bar here, your beam here, and then you have this UDL, which is 86 kilonewton per meter. Okay, so maksudnya symmetrically loaded, maksudnya reaction left and right, maksudnya RA and RB, reaction dia akan sama sebab balance. Okay, kanan dan kiri balance. Jadi samalah. Okay, sebab you ada satu UDL saja for the whole beam. Okay, along the way sampai hujung beam ni. Okay, and you have like this one like 6 meter. Okay, sama. Okay, jadi beam symmetrically loaded, obviously value of RA akan sama dengan RB, which is you just ambil this 516 kilonewton. Okay, W ni you bahagi je dengan 2, meaning that 516 kilonewton ni divide by 2. Okay, so we going to get 258 kilonewton. So what does this mean? Adakah ini maximum shear stress? Shear force. Maximum shear force. Yes. Because you know that bila you buat SFD and BMD, okay, sebenarnya you boleh agak. Okay. Biasanya maximum ni akan dekat support. Okay, bila you buat SFD BMD, okay, bila you kira RA dan RB 258. Okay, 258 here and 258 here. So dia boleh support 516 kilonewton ataupun 86 kilonewton per meter for the whole 6 meter maksudnya. Okay, jadi you memang akan tahu, okay, sebenarnya value kat sini memang 258, kat sini pun 258, sini negatif lah. Okay, sini maksudnya kat sini dekat reaction ni ataupun senang cerita dekat support ni memang adalah maximum shear force. Okay, kalau beam ni symmetrically loaded lah. Okay, maximum shear force 258 kilonewton. So obviously value ni juga adalah maximum shear force. Okay, boleh faham? Okay, so this is the maximum shear force 258 kilonewton. Alright, so after that we need to find the shear stress at cross section. Okay, kita dah tahu kan maximum shear force berapa, jadi kita boleh dapatkan shear stress at cross section. Maksudnya dekat cross section mana for yang ikut size beam tu lah. Okay. Jadi we have this 258 times 10 power of 3 Newton because kita tukar dia dalam Newton. Kita nakkan dalam unit Newton over mm square. Okay, because B here kita dah tahu it is 325 mm and D adalah 547 mm. Betul tak? Saya tak buat salah tak? Value, yes. Okay. Third, Patricia.
1.451.
1.451. Alright, Newton over mm square. Thank you. Okay, so this is the value of shear stress at cross section. Maksudnya dekat cross section of beam, maksudnya beam awak macam ni. Kan, you potonglah dia dekat mana-mana. So dekat cross section tu, inilah value V ni. Okay, and normally maximum ni akan duduk dekat hujung ni lah because of beam you dekat support tu lah maximum shear stress ataupun maximum shear force dia kat situ. Alright, so after you dah calculate the value of maximum shear pula. You dah calculate stress at cross section. Kita akan shear stress at cross section kita akan kena kena kira permissible stress. Okay, because kita nak tahu whether value yang kita dapat ni, meaning shear stress at cross section ni, is it dia exceed the permissible stress. Okay, so permissible stress, the formula is 0.8 square root FCU. Okay, kalau you masih ingat, I pernah explain this one masa bila ada. Okay, check balik lah nota ada cerita pasal permissible stress. Okay, 30 Newton over mm square. And so jawapan dia 4.3. Allah, berapa jawapan dia? 4 point berapa? Anyone can answer? Square root 38. Okay. Newton over mm square. Okay, so bila kita check dekat sini, okay, so kita bolehlah check. Kita tengok that this value permissible stress, maksudnya yang di-allow, yang boleh. Okay, maksudnya sekarang awak punya stress at cross section, shear stress at cross section tak boleh exceed this permissible stress. Permissible stress adalah maximum. You cannot exceed this value. So maksudnya sekarang you punya V, okay, V you obviously less than 0.8 square root FCU. Okay, so maksudnya okay lah. So up until now, yang kita belajar hari ini ada soalan nak tanya?
Tak ada.
Woi, yakin kau? Betul lah? Okay, so since...
So far understand.
Ya?
Faham.
Faham Okay, thank you semua.
Thank you, Miss.
Alright.
Thank you, miss.
Woi,
Thank you, Miss.
thank you, bye.